Hey everybody, welcome back to chemistry. And so you have previously learned about the nature of acids and bases. And so now what we're going to do is we're going to look at the kinds of chemical reactions they are involved in. And so the major kind is called a neutralization reaction. And so essentially what a neutralization reaction is where you have an equal amount of acid and base reacting together to form two new products. The two new products will be water and a salt. So let me just give you sort of the classic example of a neutralization reaction. And so what we'll have is hydrochloric acid. So this is the acid. And then what we're going to do is we're going to react it with an equal amount, say an equal number of moles of sodium hydroxide, which is a base. And then they will completely react with each other and they will produce two new products. And so one product is always water, and then the other product is some kind of ionic salt. And so one of the things you're going to have to get used to doing is you're going to have to figure out, given that you have a formula here for this acid and this formula for a base, can you predict the formulas for water and salt? So let me show you how you do this. And so what you imagine is happening is something called a double displacement reaction. And so in a double displacement reaction, here the cation, which is hydrogen ion here, breaks off the HCl and bumps off sodium and replaces it. And so you get HOH, which is water. So again, imagine this hydrogen ion breaking off, replacing sodium and binding to OH, and you get HOH. And so I'm going to write that as H2O. And then at the same time, this sodium ion breaks off OH and it replaces the hydrogen ion and binds to chloride. And so the other product you're going to get here is NaCl. So this NaCl is a kind of ionic salt which is called table salt. So this is just to note a very specific kind of salt. Okay. So let's go on and let's do a little bit more of a difficult problem that you might be facing. Okay, so what I want to do is I want to do this problem here where we're going to have to look and figure out a number of equations for this particular neutralization reaction. So here in this case, we are given the words for the reactants that are reacting. So we have bromic acid, and now it's reacting with barium hydroxide. Okay, so first off, we have to figure out, do we really have a neutralization reaction here? And we do if one reactant is an acid and one reactant is a base. And so you have hydrobromic acid, and so that seems to indicate that this is an acid here. And then you have barium hydroxide, and you'll recall that soluble hydroxide compounds act as bases. And so here I'm going to write base here. Okay, so now the next trick is you have to figure out the products that form. And so it may be difficult looking at the names of the acids and bases to figure out what the products are. So what I'm going to do is I'm going to write up formulas for each of the acids and bases. So hydrobromic acid is one formula that you'll have to memorize, and that is HBr. So I'll write that here. So it's HBr. And then barium hydroxide. And so how would you figure that out? Well, barium hydroxide is an ionic salt, and you can look at the location of barium in the periodic table, and you'll see that when barium becomes ionized, it has a 2+ charge, and that's because barium is in group 2. Hydroxide, I'm hoping you know by now, is OH-. And so now, can you write out the correct formula for barium hydroxide? I think what you can see is to neutralize this 2+ on the barium, you're going to need 2 hydroxide negative charges. So you're going to need 2 negative hydroxides to neutralize the barium 2+. So the formula for barium hydroxide is BaOH2. Okay, So now let's go ahead and figure out the products. And so one of the things I'm hoping you remember is that when you have a neutralization reaction, one thing you always make is water, and then you make some kind of salt. Okay, so let's figure out what the salt is along with the water. Okay, so the water is easy to imagine, right? And so what happens is H breaks off and replaces barium and sticks onto OH. And so we can just write out the formula for water at this point, which is H2O. And then we imagine here barium breaking off hydroxide and replacing the hydrogen ion and binding the bromine to form barium bromide. So the tricky part is figuring out the correct formula for barium bromide. So how do we do that? Well, let me take some room up here. And so we have barium bromide, right? And so again, barium is a 2+ ion. Bromide is Br-. And so I'm kind of hoping you can sort of figure out the formula here for barium bromide is going to be BaBr2. Okay, so if we wanted to complete the word equation here, we can just write water and then plus barium bromide. Okay, so I think the next thing we have to do is we have to balance this equation. So just to make this a little bit clearer here, I'm going to remove these arrows, which we don't need. Okay, so let's go ahead and balance this chemical equation. And so let's see, it looks like we have 2 bromine atoms as products, 1 as reactants, so I think we're going to have to put a 2 here like that. And then I think what we'll have to do is balance the O's and the H's because we have more as reactants now than as products. And as I recall, to balance the O's and the H's, we put a 2 here. And I think if you count carefully, you'll see that on both sides of the equation, we have 4 hydrogens and 2 oxygens. Okay. Now, what I want to do is write out a general ionic equation for this neutralization reaction. And this is sort of done in a similar way that we did it for precipitation reactions, in that what we do is we write out ions for all soluble compounds that dissolve well in water. So let me go ahead and do that. So we'll first do the reactants. And so here we have hydrobromic acid, and we have 2 molecules of that. So for the general ionic equation, let me write here general ionic equation. It's also called a complete ionic equation, just depends on the book you're looking at. So here what you have is we're going to have 2 hydrogen ions, right? And this will be an aqueous solution. And then we'll also have 2 bromide ions, which is also an aqueous solution. Okay. Now, barium hydroxide is also soluble in water, and so we need to write these out as ions. And so we'll write Ba2+, an aqueous solution, and then 2 hydroxides, an aqueous solution. Okay, so far so good. Now what we have to do is write out the ions as necessary for the products. Now, do we write out water as ions? And the answer is no, because most of the water molecules in water are not found as ions. In other words, when you're looking at water, you don't see very many H pluses or H3O pluses and OH minuses. Most of the water molecules you will see in water molecules are H2O. So we cannot write out H2O as ions. And so we just have to write it out as the molecule. So I'm going to write here 2H2O. And so here water, if you want to, is you can either use a state symbol for aqueous or you can use as liquid. I prefer to use as liquid here because here in this chemical reaction, one of the things you might be noting is that we are reacting hydrogen ion from one compound with hydroxide ion from another to form water. And so that should be at the liquid state at room temperature and pressure. So I'm going to write L here for liquid. And then we have some products, which are barium bromide. Those are soluble in water. So I'm going to write plus Ba2+ aqueous plus 2 bromide ions aqueous. And so I think that should be fine. So that is the complete ionic equation. Now, is there a net ionic equation? Well, yes, there is. Now, remember when we were writing out a net ionic equation for precipitation reactions, we would write the equation that describes what ions bind together to form the insoluble precipitate. Here it's a little bit different. Here we describe the ions that bind together that form water molecules. Okay, so here with the net ionic equation, again, we're going to be looking at the formation of water molecules here. If you want, you can say 2H2O, and this will be in the liquid state. And so what binds together to form those two water molecules? You have two hydrogen ions here, and then you have two hydroxide ions here, and they will bind together to form two waters. It could be that maybe on a homework problem they're going to ask you to rewrite this equation so that the coefficients are reduced to the smallest numbers. And so if you really want to do that, since all of these ions and molecules have a 2 in front, they will divide out. And so you could write out the same equation, but just with one of each ion forming one water molecule, and this would be a correct answer as well. So that's the net ionic equation. And so the final question you may be asked is, in this neutralization reaction, what are the spectator ions? And so the spectator ions are the ions that watch the formation of the water molecules. And so what are those ions here? So those ions are the product ions here, again, that watch the formation of water. And so the spectator ions are, it looks like barium and bromide. Okay, so now let me go over to the computer now, and what I want to do is I want to talk about how you're able to identify a neutralization reaction. And so one of the things you're probably going to have to do on a test, on a homework assignment, is you're going to have to look at a particular chemical reaction and figure out if it qualifies as a neutralization reaction. And so what you have to make sure of is that one reactant is an acid, it could be a strong or weak acid, and one reactant is a base. It could be a strong or weak base. So for example, in this example that I have here on the screen, we have an acid here, which is hydrochloric acid, happens to be a strong acid. And then we have it reacting with a base, which is sodium hydroxide, happens to be a strong base. That will be a neutralization reaction, and you'll form water and the ionic salt. So let's go through and look through these next reactions and figure out if they are examples of neutralization reactions or not. Okay, so here in this first reaction, I'm hoping that you recognize H2SO4 is an acid because there's an H in front, and this happens to be sulfuric acid. So this is definitely an acid, okay? Now, the question is this, is the other reactant a base? And the answer is no. Sodium chloride is not a base, and the reason is it doesn't have hydroxide in it, for example. So this is not a base. And so, again, to have a neutralization reaction, you must have an acid and a base. Here, as reactants, we only have an acid, so this is not a neutralization reaction. Let's go to the next one. So in the next one, what you can see is that we have an acid, which is acetic acid. You know it's an acid because there's an H in front here in the formula molecule. And then we have a base here, and the base is sodium hydroxide, and the way we know that is because this is a molecule with hydroxide. So we have an acid and we have a base, and they are forming water. Here you can see that, and a salt. And so this is a neutralization reaction. All right, so let's move on to the next one. Okay, so let's look at this first molecule. Is this first reactant molecule an acid or a base? Well, I don't see an H in front of the formula here, so it's not an acid. I don't see hydroxide here, nor is this ammonia, for example, so this is not a base. So this is neither an acid or a base. Now the second molecule is a base here, but remember, a neutralization reaction requires an acid and a base. So we only have a base here, so this is not a neutralization reaction. Okay, and the final reaction, we have nitric acid here, and I know it's an acid because we have H in front of the formula. And then we have a base here. barium hydroxide. I know it's a base because there's hydroxide there. So we are reacting an acid with a base. And so in this case, the acid happens to be strong and the base happens to be strong. That's fine. It doesn't really matter the strength of the acid or the base. It just matters that you have an acid and a base. When you have that, you have a neutralization reaction. Okay, moving on. What I need to do is go over a specific kind of neutralization reaction called a titration reaction. So first, let me tell you what the goal of a titration reaction is. The goal of a titration reaction is to figure out what the concentration of one particular solution is by adding a certain volume of another solution with a known concentration. But what I want to do is sort of focus in on something called an acid-base titration. And so let me show you how this may be carried out. So let's say you have some hydrochloric acid and you do not know what the concentration is, but you want to determine its concentration to a very high level of precision, say 4 significant figures. How would you do that? Well, the first thing you want to do is you would put some in a flask and then you write down exactly what volume of the acid you have there. And so let's say you have, for example, 50 milliliters of the acid. So the next step in the titration is add base to the hydrochloric acid. And so the way we dispense the base is through something called a burette. So down here in the flask, I have the acid, and so I'm just going to indicate that this is relatively acidic by just noting here that there is H3O ions in the acid. And then here above the acid, we have this long glass tube, which is called a burette. And so in the burette, you would have something like sodium hydroxide, and so therefore there'll be hydroxide ions in the burette. So very importantly, we can find out what the exact concentration of the hydrochloric acid is if we know the exact concentration of the base. And so when you add base to the burette, one of the things you just have to sort of know is what the concentration of that base is. And so let's say it's 0.250 molar in this example. Now, whenever you add a solution of known concentration to figure out the concentration of an unknown solution, like what we're doing here, the solution of known concentration is called a titrant. So that is a word that you have to know. Now, another thing you have to do to carry out this titration is you're going to have to here, into this flask of acid, add an indicator dye. And so the indicator dye we're going to add is a particular kind called phenolphthalein. And so I'm just going to write P here for phenolphthalein. And so just to note that we're going to have to add this indicator dye to the acid solution before we start adding base to the acid solution. So why do we add this indicator dye to the acid solution? Well, the reason is that the indicator dye will change color when you completely neutralize the acid with base. And that will happen is when you have as many moles of hydroxide as moles of hydronium in the solution. So in this slide, we have some pictures of the process. And so you can see here that we have acid here again, down here. And then here in the burette, they're opening up the valve of the burette. And you can see here we have sodium hydroxide here that's dripping and going into the acid. Now, at first, you're going to have a lot less hydroxide from the sodium hydroxide than you have hydronium from the acid. And as long as you have those conditions, the indicator dye will remain clear. However, you're going to get to this point here. Here at this point, what happens is you've added exactly enough base such that all hydronium ion molecules in the acid are neutralized by hydroxide ion molecules. When you get to this point, it is called the equivalence point. And again, at the equivalence point, you have completely neutralized the acid with base. And so what that means is that you'll have as much hydroxide moles as hydronium. So the question is, how do you know you get to the point? Well, that's where the indicator dye comes through. And so the indicator dye at first is clear, but just at the point where you've added just enough hydroxide to match the hydronium, it turns purple. And so then you sort of stop the process. So the final step is to calculate the concentration of acid you had originally. So the way you do it is this. You note the concentration of base that you were working with, and you note the volume of base that you added. Then you'll know what the original volume of acid you had was, and from these numbers you can go about and calculate the concentration of the acid. And so we're actually going to be doing some of those kinds of calculations later on in Chapter 5. So thank you for listening to this, and we'll see you next time.